At DD this year, I presented a talk on applying playgrounds to multiplayer level design. Because this was a short talk, I focused on the application to level geometry and the consequences on multiplayer systems. If you have followed my blog for the last few years, you will know my interest in playgrounds is not new. They are a metaphor I have used several times as an example of how digital games should adapt to their players' needs. What follows is my framework for these ideas in multiplayer level design. There are still many areas to explore in this space, some of which I outline along the way. But I hope this introduction to the playground metaphor helps you in your own explorations. The basics. Playgrounds are persistent community spaces for non-prescriptive play. A playground is not an obstacle course to complete, a puzzle to solve, or a story to hear. There are aspects of obstacle courses and stories, but they are not consumed through player interaction. They persist. A good playground facilitates many obstacle courses, many stories, and many forms of play. Playgrounds are places to be, not levels to beat. Playgrounds are multiplayer. Playgrounds are fundamentally multiplayer spaces. They support a wide range of player needs, and they scale along game mode, player count, and player trust. Raph Koster and a team with Google explored the idea of a trust spectrum in games. The idea is that different multiplayer activities call for different amounts of trust, which can create barriers for unothers. If a game supports basic parallel play, alongside intense, cooperative reads, there is not a path for new players to build the trust they need for the harder activities. Playgrounds also support a trust spectrum with a range of play, from solo and parallel activities up to group competitive and cooperative play. As multiplayer spaces, playgrounds also follow some design patterns for building friendship. The activities encourage proximity and reciprocity between players. Here, for example, are several activities as part of a playground. Players can enjoy some activities alone or in parallel. Other activities require multiple players, some with turn-taking, others with players working together, which means reciprocal loops that build trust. These activities also do not lock players in for long. A player can stop in the middle of an activity or at the end of turn to opt out of play. When I describe playgrounds as community spaces, I also mean more than the play structures. The community space includes the surrounding park, the walking paths, and benches. Playgrounds include spaces for parents to sit and talk while their children play. This is an area I want to explore further in video games. But what could serve the function of a park bench in other multiplayer game systems? Playgrounds, not sandboxes. There is some overlap between playgrounds and sandboxes worth clarifying. For me, a sandbox is a neutral space where players bring toys. In contrast, a playground is the toy. Sandboxes are also used up through the act of play. Often a player will need to start a new game at the sandbox to reset. The main overlap between these terms is that both allow non-prescriptive play. That is, sandbox and playground design both let the players do what they want, instead of forcing one way to play. Sandboxes best support solo and parallel play, but not reach cooperative or competitive experiences. This may be a consequence of genre convention, more than a necessity. When I say that sandboxes are neutral spaces where players bring toys, I mean the individual players upgrade trees, loadouts, and equipment. Because these are not shared, are passed between players in turns. The game systems encourage each player to specialize in a way that may conflict with deeper cooperative play. For example, in Saints Row IV, there are a finite number of activities and collectibles in the world, and the act of play depletes this world of its potential. While exploring the world cooperatively, there are few activities that require both players. As we level up, we can each choose to spend our skill points differently. If I focus on enhancing my character's movement abilities, while you focus on combat, then the systems are pushing us away from cooperation. You will not be able to catch up with me while I scale the buildings, and I will not be able to fight alongside you when you attack harder enemies. Again, the emphasis of the sandbox design is on the toy skill upgrades, in this case that each of us collect and bring to the neutral space. Instead of the space being a persistent toy, both of us to share. My focus with this post is on level geometry, but the way we shape our levels affects multiplayer systems. If we play Deathmatch on a King of the Hill map, the game may still play like King of the Hill. This is because level geometry and game systems work together to create the play experience. The formula. Now let's dig into some examples. Here is a basic playground from my neighborhood. If you live in North America, you are probably familiar with playgrounds like this. As playgrounds go, this one is simple and unremarkable. Importantly, we cannot convert this structure directly to our video game levels, and we would not want to, but there are lessons we can take from its design. The basic unit of a playground is a module, a self-contained chunk. At the center of the module is a platform elevated off the ground. This playground is for young kids, so remember this platform is a meaningful vantage point for a 5-year-old. This means it functions as a goal for that player to attain. In order to reach the platform, the goal, the player must pass a skill check. Here that skill check is a staircase. Importantly, a good skill check is not a binary pass-or-fail. The player can fail and trip on the stairs, but most use falls into a range of skill. For the 3-year-old, slow. For the 5-year-old, okay. For the 10-year-old, maybe 2 steps at a time. Remember the multiplayer context for these skill checks. If I can take the stairs 2 at a time in a game of tag, and another player cannot, then there is a tactic I can exploit around the playground. On reaching the platform, there are rules back down that function as rewards. Here they take the form of slides, which are also opportunities for subversive play for the skilled player who will risk running up the slide. Subversive play is whenever the player thinks they are using a constraint of the design against its intent. We can design with some subversion in mind, but the flexible form of playgrounds should allow for more subversive play than we can predict. Against the bars at the back of the platform, there is a steering wheel. This functions as a setpiece, which landmarks and differentiates modules from each other. In playgrounds, a good setpiece can also spark imagination and encourage role-playing. For now, the aesthetic and thematic solutions to the playground formula is a problem to save for another time. Now that we have a formula, we can create more complex forms. This playground is more interesting than the first example, because it connects multiple modules into a complex structure. Here we have a hierarchy, or tree. This makes a fun playground. But there is still a problem in the lack of cycles or loops. If we play tag on this structure, the only ways to go from one end to the other are by backtracking, or by running on the ground. But with our abstract language of modules, we can imagine variants that do connect as cycles. With these formulas, we can now imagine infinite, sprawling playgrounds if we want. But our imaginary playgrounds do fit a constraint of safety. Real playgrounds are safe environments for failure, where the design limits risk. Playgrounds also limit the time to recover from a failure. If I lose my grip while crossing the monkey bars, I lose a few seconds of progress before I can try again. In games, if the player fails a skill check and cannot recover in a short amount of time, then the level lacks the safety of a playground. If the player lost a save state, we have designed something where recovery is too difficult. This may limit how big a playground can be and what systems we can use. Applying the formula to level design. For most of my experiments with the playground level design, I have used Quake. The most direct application of playgrounds requires a robust set of skills, which Quake has. A staircase in Quake is not a meaningful skill check. But once we add a monster at the top, there is some skill involved. Another benefit of testing these ideas in Quake is that all levels support single-player, co-op, and competitive play. Once we adapt the level geometry, we are close to my definition of playgrounds. There are also many ways to create timing-based skill checks around moving obstacles, traps, and dynamic cover. For a game 2 decades old,